So let's say we have this set number function, which might be internal, and we want to set a number to new number, but not bigger than 10. So we can write something in the beginning called require the new number to be less or equal to 10. So what this does when we execute this function, it will first check if the number is below or equal to 10, and if yes, then it will continue. If not, we can also supply the second parameter, which is the error message, and we can write number is above. This means if the new number is bigger, basically this condition when it will fail, then here we can write the reason. The transaction or the function will be reverted, it will not continue. So this way we can write some checks before we even start executing the function with the require, the condition, and the error message if the condition did not pass. But let's say we have this condition also in other functions and we want to reuse it. We don't want to type it in every function or the function which requires it. So then we can use something special called modifiers. So let's define our modifier here, which starts with the keyword modifier, and we call it above. And in this modifier we will specify that require statement which we defined here. So let's copy paste this and put it here. And what we need to do after all the requires, we can have one, we can have multiple, we need to write something like this, underscore colon. This is some special syntax, and also we will need to pass the new number, which is of type uint 256. So now we can take this modifier and paste it in the end in our set number over here and pass there the variable which we require. So this way, as you can see, now our function become much clearer, and in the beginning it will execute this, which are the requires. So if you have now more functions, we can just reuse this and we don't need to write the same require over and over again. Also, when we want to adjust the require, we can just go to this modifier, adjust them here, and basically they will be automatically reflected in our other functions. Pretty cool, right? I will also mention 3 special variables which you have access to. So there is one called now. As you can see, it's highlighted in bit green, which gives you the time right now in epoch time format in milliseconds. Then there is something called message.sender, which means the address which executed this function. Currently it's internal, but if we would change it to external, then the person from which function this function was executed, we would have his access to his address here. So we can either check if it equals to a certain address, or we can store it or whatever. So from the front end, when the person would be from the MetaMask executing this function, then the address of that person or the wallet would be represented as this value. There is also message.value when the function is payable. Let's make it. That means we can see the value the person or the wallet is sending to this function, and we can check if it meets the criteria or not in our require statement. So message value, message.sender, and now are the 3 special variables which you have also access to. Moreover, can be read at the Solidity documentation. There is like a lot of it, but I'm trying to compile the most important so you can start right after programming with very good understanding of the fundamentals. So I'll just keep them here commented. And I think that covers the fundamentals of the functions, modifiers, requires or restriction checking, the special variables, visibility accessors, return statements, and you are ready to go. If it was too much in the beginning, just watch the video again and it should make more sense. But before we move on to writing our own contract, I will just rename this one to test, as we are mostly testing here, and I will keep this contract in the code. And we will create our own new contract as the poll.sol.